As North America pursues greener goals, it is expected that more people will adopt cycling as their primary method of transportation. However, many North American roads were not designed with cyclists in mind. Some roads don't have any bike lanes to speak of, and many of those that do are nothing more than additional paint on an already narrow laneway. Therefore, having a combined road where multi-ton vehicles are speeding past cyclists is a recipe for disaster. When vehicles impact cyclists, the mismatch in size and mass may result in a cyclist's serious injury or even death. Evidently, any means to improve the safety of motorists before, during, and after an accident is of vital importance to all who share the road, and more specifically those who travel by bicycle. The Cyclops Ride Assist, or CRA for short, is an easily mountable and quick to set up system that adds modern car safety features onto any bicycle. It aims to provide cyclists with a simple to use ride monitoring system that decreases the risk of an automobile accident and provides valuable data in the event of a crash. Features include rear view detection and alerting, crash identification and response, as well as video and data logging of 70 seconds prior and post-crash. These properties allow cyclists to have the ultimate peace of mind when traveling from their start to finish. Let's take a closer look at the features that the CRA has. The first feature is rear view detection and alerting. With the average speed of a cyclist on the road around 25 km per hour, having a vehicle approach from behind at a much greater speed of 50 km per hour could lead to a very nerve-wracking experience. Using our rear view detection algorithm, a LiDAR sensor, and an LED indicator, when a vehicle approaches the bicycle, the user will be alerted as the distance between the two lessens. Using a gradient of colors from green to red, the cyclist will be alerted of the distance, with green indicating a further distance and red indicating a much closer distance. This will allow the cyclist to immediately note any dangers or possible hazards without having to take their eyes off the road. The second feature is the accident identification and response algorithm. With the rise of dashcams in automobiles to record accidents, interesting footage, and possibly to prevent insurance fraud, it is imperative that bicycles have these features available and accessible as well.
So we're actually using an accelerometer to detect the bike tilting, and by the way of it tilting, we decided if it was a crash or not. In order to have a good algorithm, we did rigorous testing to optimize it to make sure that when it's tilted a certain way in the X, Y, or Z direction, that will actually show that as a crash rather than just a bike tilting because you put it on the side.
Our crash detection system uses an accelerometer to accurately determine when an accident does occur. The acceleration values are checked 5 times a second by our software and logged into a CSV file. This ensures that when a crash occurs, the CRA will immediately respond. Our last feature is an automatic video and data capture of the last 60 seconds prior to the accident as well as 10 seconds afterwards.
Every time you get into a crash or you hit the capture button that's on the side, it records the video and a bunch of other data that is collected and puts it on a flash drive that comes with the product. And what you can do is you can just plug this thing straight into your computer, then you can look back on the video to see what actually happened during the crash.
This component of the CRA actually makes our system an upgrade to a traditional vehicle dashcam. With a traditional dashcam, footage is constantly uploaded into an SD card but requires manual intervention by the user to find the little snippet they are looking for. When the SD card gets full, you can imagine how tiring it would be to sort through all the footage to find just a couple seconds. With the CRA's video and data capture, the footage that the user wants is easily accessible in our storage. Furthermore, by only snipping around a minute worth of footage, we save space in our storage for additional captures later on. Our data is then plotted inside a CSV file, as mentioned above, which allows for the user to determine how the crash occurred and to allow for accident recreation and for future in-depth analysis.